All right, in this video and the next video, we want to learn about what the graphs of rational functions look like. We've talked about how to factor them, how to add, multiply, and divide. What do they look like visually? And I'll show you here what we call the parent function looks like. The parent function is like the function that all other rational ones are based on, and it's 1 over x. It's also sometimes called a reciprocal function. So 1 over x, what does it look like? When you graph it, it looks like this. It has, almost looks like, actually let me use a different color here. It almost looks like the exponential graph, like an exponential decay graph right here, but then it has another part to it over on this side. So it has like two parts to it. In order to understand why it looks like that, we have to know what these terms mean right here, vertical and horizontal asymptotes. So first of all, the vertical asymptote, notice what happens here at what I'm about to draw in green, this green line right here. Notice how that curve gets really close to it, but it never actually touches it. That's called a vertical asymptote. It's a line that a graph gets really close to. Like if you were to follow this up, it would get closer and closer and closer to that green line, but it would never touch. What is the equation of that green line? And the answer is x equals 0. That's what the vertical asymptote is. Why is it that the graph gets really close to 0, really close to x equals 0, but never touches it? And here's why. Let's take this function right here and let's plug in values that are getting closer and closer to 0. So I'll make x equal to 1, and then we'll make it 0.01, and then we'll make it 0.001, and then we'll make it 0.0001. When I do that, what is f of x or y? Because those are interchangeable. What does that equal? 1 over 1 is 1. This is 10. This is 100. Actually, I'm sorry, I skipped one there. That's 100. That's 1,000. This is 10,000. There should be a 1 over 0.1 right here, which would be 10. Okay, what's happening to these numbers? As x gets closer and closer to 0, y is getting bigger and bigger. In other words, y is shooting off to infinity, and that's what this line is doing right here. It's going up forever. And the same on the other side. Down here, it's going down because these x's right here are negative, so you'd be plugging in really, really small negative numbers. And that would make y very, very large. So that's why the asymptote occurs at x equals 0, because you're not allowed to plug 0 into the bottom of a fraction. If you put that in a calculator, what I just wrote there, 1 over 0, you get an error. You can't divide by 0 because it's almost like giving you an infinite answer. Soon as you know the vertical asymptote, you know what this is, because the domain refers to the set of all possible x values. So if we look at this equation, what can x equal? X can equal anything except for 0. It can equal anything except for 0. Why can't it equal 0? Because there's an asymptote at 0. X never actually reaches 0. It only gets really close. So as soon as you know the asymptote is x equals 0, you also know the domain is x cannot be 0. Again, why can't it be 0? Because there's an asymptote there. There's another asymptote on this graph, and it's, let me do maybe a brighter color so you can see this. Actually, that's even worse. Let me try do blue instead. So this blue dotted line that I'm drawing here, this is the line y equals 0, and that is called a horizontal asymptote. Okay, what is a horizontal asymptote? So I'm just going to write that here. A horizontal asymptote is the same as a vertical, except it's stretched out horizontally. It's something that gets really close to horizontally, but never touches. So if you look at this, I'll trace in a different color. If you look at this here, if you were to keep following this out, it would get closer and closer and closer to 0. And vice versa here, this is going to get closer and closer and closer to 0. It will never actually touch though. This happens, so the vertical asymptote happens when the denominator equals 0. The horizontal asymptote happens as x goes to infinity. So this one is as x, or as I should say, the denominator approaches 0. The other one, the horizontal, happens as x goes to either positive or negative infinity, and that's what that symbol means right there. That's sideways 8 is like infinity symbol. That's supposed to say positive or negative. Okay, why does that happen? Well, let's use this same reasoning that we used down in green. We were dividing by all those numbers close to 0. Let's use that same reasoning for infinity now. So obviously we can't divide by infinity, and that could be f of x. We can't divide by infinity, so let's just divide by bigger and bigger values of x. So let's say x equals 100, x equals 1,000, x equals 10,000, and so on. What does y equal? 1 over 100 is 0.01. This is 0.001. This is 0.0001. So what's happening as x gets larger and larger? Okay, which is this part of the graph right here. As we're going this direction, x is getting bigger and bigger. What's happening to the y's? And you can see from looking at them, the y's are getting closer and closer to 0. They're getting smaller and smaller. So that is why we end up with an asymptote. The question is, does it ever actually reach 0? And the answer is no. Because no matter how big a number you divide by, think of division like pizza pies. If you take one pizza and you divide it among a trillion people, among a quadrillion, a quintillion, however large a number you want, I mean, you'll get to the point where it's practically 0. Like you couldn't even really divide it practically something into that many pieces, but you would get really, really close to 0. You get an incredibly tiny number, but it would never actually reach 0. Okay, so then what's the range of this function? Remember, the range refers to all the y values, and it's the same idea. Okay, because y doesn't actually reach 0, that means the range is y can't be 0. That's what we mean by vertical and horizontal asymptotes. In the next video, we will talk about how to do a complete graph of a rational function. There are 3 different cases, and I'll show you how all 3 work. We'll see you there.